Let's continue our discussion with particle motion by looking at a graph. First of all, we want to look at all of those things that we learned with curve sketching. Now we want to apply them to particle motion. So important then when we look at this graph that we recognize that we're looking at the position graph. Remember, that's just like we're looking at the function graph. So when we're asked for at which points is the velocity equal to zero, really we're saying where is the derivative equal to zero? So I want you to think of those tangent lines. Where would the slopes of those little tangent lines be zero? Well, I've got one at x equals b or at b and d. And this is where the derivative, the velocity is zero because the slope of the tangent line is zero. That will be our justification. Okay. Now, where is the second derivative equal to zero? So you're looking at the function. The second derivative is asking you about the acceleration is asking you about the second derivative. So remember, the second derivative is equal to zero where the function has a point of inflection. So this question is really saying, where are the points of inflection? Like, where does this change from concave up to concave down? And where does it change from concave down to concave up? So I see for concave down. Right here, we start changing to concave up. Remember what concave down looks like? Looks like a parabola turning down. Concave up looks like a parabola turning up. So we're going to be changing concavity at the point C. And the reason is because concavity changes. Okay, on what intervals is the velocity positive? So on what intervals is the first derivative positive? So we know the first derivative is positive where the function is, you're right, increasing. So this is really asking me, where is f of x increasing? I'll just translate over here, okay? Remember, particle motion is just like curve sketching. We're just asking it with a velocity and acceleration. So where is the function increasing? Well, it's increasing on the interval from negative infinity to b, and then again from d to positive infinity, because we'll justify f of x is increasing. Okay, on what interval is the velocity negative? So in what interval is the first derivative negative? This is asking us, where is the function decreasing? The function is decreasing from b to d because f of x is decreasing. Now, you'll be the translator, right? You'll be the one who needs to read this question and translate that into what you're actually looking for. Okay, next, on what interval is the particle's acceleration positive? So this is telling you, asking you, where is f of x concave up? So it's asking you, where is the second derivative positive? So on here, where are you concave up? Remember we changed concavity at C, so we're concave up from C on to positive infinity because f of x is concave up. And the last one then, where is the acceleration negative? And this is where are you where is the function concave down? And that's on the interval from negative infinity to c because f of x is concave down. Notice with every one of my justify answers, I say because, and I say the reason why. I say what I was looking at on this graph. You don't have to get wordy. I didn't write a book, right? A few words to say exactly what it is that I'm needing to explain. Okay, so the next thing I want to talk about is the five commandments of particle motion. So even if you're not a physics person, you haven't taken any physics classes, these five commandments are going to help you know enough for what you need to be able to do on the AP Calculus AB exam. Now, these commandments apply to particle motion where the particle's moving along the x-axis. So you may need to pause this video so that you can write these five down because they're going to be something that we look back on and we use, and you'll want to make sure that you know them. So my physics people, you may know these already, may be common sense to you. But for those of us who don't have a huge physics background, these may be something you're going to have to put on a note card and continually look back at so that you can refer to it. So you'll be able to do everything that you need to do for the AP Calculus exam. That being said, we're going to focus our attention on the examples. And again, if you need to pause the video to write these down, I think it's worthwhile that you have them. So let's go ahead and look at some examples then. Suppose the velocity is given by this function, where t is measured in minutes and the velocity is measured in inches per minute. So we want to find the values of v of t, v of 3, and v prime of 3. And then based on these, we want to describe the speed. So v of 3, since we have the equation for the velocity, we're just simply going to plug in 3. So I've got 3 plus 2, and I've got 3 plus 4 squared. So 3 plus 4 squared is 7. 7 squared is 49. 49 times 5 is 245. Okay, and that's in velocity, which we were told is in inches per minute. I kind of want to get in the habit of making sure I put the units on there. Then we need to find the derivative. So let's find the derivative in general, and then we'll plug in 3. Product rule, so we've got first times derivative of the second. I didn't mean to put a parentheses there. Times 2 times t plus 4 plus the second times the derivative of the first, which is 1. Now see that both of these have a t plus 4 in them. So I'll go ahead and pull that out, which leaves me with 2 times t plus 2 plus, oops, excuse me, plus t plus 4. I apologize, that's a little messy there. I'm going to clean up that second parentheses. I've got 2t plus 4 plus t plus 4. And that gives me 3t plus 8. Now we want to plug in 3 for that. So v prime of 3 is going to be 3 plus 4 times 3 plus 8. So that's 9 plus 8, 17. 17 times 7. 17 times 7 is 119. And that's in inches per minute squared. Okay, now based on that, we need to know the speed. Now the speed of the particle when t equals 3, speed is the absolute value of the velocity. Speed is the velocity without direction. So the velocity was 245, and so the speed is 245 inches per minute. So the velocity tells us the direction that an object is going as well as how fast, but the speed tells us just how fast, no direction at all. Okay, now look at B. B's asking us, okay, on what intervals is the particle moving to the left? This is meaning, on what intervals is the first derivative negative? Because remember, number 2 in our commandments is if the velocity is negative, the object's moving to the left. Here's our velocity. I need to know when it's moving to the left. So in order to know that, I've got to know, first of all, where the velocity equals 0, i.e., I have to find my critical points. That should sound familiar. We've done that, okay? So I get that t is -2 and -4. Now, you're going to be shocked, but I'm going to go with a number line. Friends, we've done this, okay? If you can translate it from moving to the left to derivative being less negative, you're going to realize that we're doing the same thing that we've done before. Putting those values on the number line. Now I'm testing it. For this interval, let's test t equals -5. Okay, so I get a negative, and I get a negative, but I square it, so it's positive. So I get a negative times a positive. That's a negative. Test t equals -3. That's a negative. This is always going to be a positive because it's squared. So I have a negative times a positive, which is a negative. Then put in 0. Positive, positive. Okay, make sure for AP purposes that you label that number line. And now we're looking for, let's see, the object or the particle moves to the left on the interval from negative infinity to -5. Oops, we're doing it from, notice our interval here, from t being greater than 0. Let's fix that then. If we're starting at 0 and we only move left when we're less than 0, so then we got to say the particle, let's fix this. The particle never moves left. Never moves left for t is greater than or equal to 0. Okay, so watch your domains. I should have highlighted that from the very beginning. That was very important. So it never moves left as long as t is greater than 0. All right, let's look at a free response question. And this is one that actually showed up on the AP exam. We're being given the graph of the velocity from 0 to 50. And then we take these and we put the values in the chart. That's what they did. Okay, so these values and these values represent the same thing. During what interval is the acceleration positive? So if this is the first derivative graph, because velocity is first derivative, and acceleration is second derivative, I'm really asking you, where is second derivative positive, knowing that this is the first derivative graph. So I'm really asking you, where is this graph increasing? Where is this graph increasing? Well, that's going to be from 0 to 35 and from 45 to 50. Give a reason. Because velocity is increasing. Curve sketching terminology with velocity and acceleration. Okay? Find the average acceleration from 0 to 50. Average means slope algebra way. So we're going to find average acceleration. We're going to do it as the velocity at 50 minus the velocity at 0 all over 50 minus 0. So go to your chart. Velocity at 50 was 72. Velocity at 0 is 0. And then we just need to divide, right? 70 divided by 52. I'll punch that quickly into my calculator. I'm sorry, I said that backwards, didn't I? 72 divided by 50 will be 1.44. Now my units. Velocity is in feet per second. Time is in seconds. So I've got feet per second, or I've got feet per second squared. All right. Now, C says find one approximation for the acceleration at t equals 40. So I want one approximation for the slope of the tangent line when t is 40 here. Okay. So we're going to say the acceleration at 40 is about, and we're going to do the slope algebra way since I can't do the slope calculus way. So I'm going to do the slope around 40. I'll use 45 and 35. Okay, so go again to your chart. Velocity at 45 is 60. Velocity at 35 is 81. And 45 minus 35 is 10. And that gives me negative 2.1. Once my units again, so acceleration, we just went through that, is velocity feet per second, or feet per second squared. All right. Now, the speed of the car. The speed of the car, is it increasing or decreasing? So remember, our particles of motion commandments. The speed of the car is increasing where velocity and acceleration have the same sign. So let's see, velocity at 40, I don't care about the value, I just need to know positive or negative. Velocity at 40 is 75. Acceleration at 40, look at part C, we just found that it's negative. So because acceleration and velocity do not have the same sign, the speed is decreasing. Go back to your 5 commandments of particle motion. The speed is decreasing where velocity and acceleration have different signs because v of 40 is positive and a of 40 is negative. And we justified our answer. Can you see how this is all going to work together on a free response question? I hope you do because it is one of the topics we see most every year on our free response question. So remember, you get 6 free response, and this is a topic that shows up a lot as one of them. I think it's a topic that's well worth our time making sure we understand it. So leave me some comments there in the bottom, in the comment section. If you need some more help with this, I'd be glad to help. Bye for now.